In this video, we're going to start chapter 6, Benzene and its derivative. Okay, in this video, we focus on the aromaticity of the benzene, chemical structure, resonance structure of benzene. So just recall back, benzene, the structure of the benzene is a hexagon with 3 double bonds, double single, double single, double single, or a hexagon with a ring in the middle. So, and then the chemical formula for benzene is C6H6. So basically, if you look at the chemical formula given, the ratio carbon to the hydrogen is mostly 1 to 1. Then we know that the structure consists of one benzene ring. So look at the tutorial question number 1. State the characteristic for an aromatic compound. Okay, so which means is aromaticity here. So to fulfill the aromaticity, they need to have fulfilled 4 criteria. So the first one is cyclic, and where we can see there is a hexagon, so it is a cyclic compound. Second is planar. So basically, if there is sp2 carbon, so the structure will be considered of planar, okay, because of carbon double bond. Then the third criteria is completely conjugated with uninterrupted cloud of pi electron. For this, too simple to say, there is double and single bond alternate. Double and single bond alternate each other. So the fourth requirement is need to obey the Hager's rules, and where we know this need to fulfill the formula 4n plus 2 and then equal to number of pi electron. Okay, then if the n is equal to integer, which for example 0, 1, 2, 3 and so on, means that they are obey the Hager's rules. So let's look at what we understand about the pi electron. Okay, electron for pi bond, okay, is considered of pi electron. Like just now we say that a benzene ring consists of 3 double bond. So 3 double bond. So once we have double bond, first bond is the sigma, second is the pi bond. So in every pi bond, we have 3 pi bond, and every pi bond have 2 electrons. So it will equal to 6 pi electron. So then we will look at use the formula 4n plus 2 equal to 6. So 4n equal to 6 minus 2, and the n is equal to 4 over 4, which is equal to 1. Therefore, from here we know that benzene fulfills the all 4 requirements, which is the cyclic, planar, because consists of sp2 carbon, and they are completely conjugated, which means double and single bond alternate each other, and obey the Hager's rule, use the formula 4n plus 2 equal to number of pi electron, and then determine the value of n. When it is integer, means that fulfill Hager's rule. Like we mentioned before, after we knowing the general idea for the benzene, then next one we need to know the naming and also draw. Okay, we need to draw and also name the benzene. So they may have 1 substituted, di is 2 substituted, tri or even tetra substituted. Okay, and then we have learned about the IUPAC name. So in this chapter, we're going to learn 2 new substitutes which consists of the benzene ring. So C6H5 is the phenyl. So if we look at the structure this is the substitute. Okay, if C6H5CH2 means that this is the benzene ring connected with CH2, and then one of the bond is bonded to parent. Okay, so like this, we know it as benzene. Okay, now we look at the first part, mono-substituted benzene. When we mention about mono-substituted, means that there is only one substitute. So fluorine will use fluoro, bromine will become bromo. Okay, and then CH2, CH3, ethyl, NO2 when is known as nitro. Okay, then for right hand side here we have a special name. We are not using the IUPAC name. So basically at the left hand side here we call IUPAC nomenclature, and then at the right hand side here we know the name as common name. Okay. If a benzene ring attached to a methyl, the IUPAC name is known as methyl benzene. But at the same time, we also can note it as two-ring. So if a hydroxyl group attached directly to the benzene ring, we call substance as phenol. NH2 attached directly to benzene ring is aniline. COOH attached directly to benzene ring is called benzoic acid. And this one is phenol because there is ketone, and then with two carbons, so basically is acetol phenol. And then this acetone group attached to the benzene ring directly, so we use phenol. And then when there is one functional group aldehyde attached directly to the benzene ring, we will note it as benzaldehyde. If there is two substitute, we call it a disubstituted benzene. So similar with previous case, we have to identify the name of the substitute, and then we need to give the name follow the alphabetical order. Okay, however, look at the first example here. We have both substituents which are the same and that is next to each other. So we will give 1, 2, okay? Because we need to give lowest number to the substituent and then followed by the alphabetical order. So in this case, if we name it, it will be known as 1,2-dibromobenzene. However, this 1,2 can be simplified as O, which is basically means called auto. Okay, then now we look at the second example here. We have nitro and O2, and then we have fluoro. So in these two cases, either one can be nitro can be 1, and then we have to clockwise 1, 2, 3. Because if we make it anti-clockwise, it will become 1, 2, 3, 4, and 5. 1 and 5, the number of carbon, the total number for the substituent is higher. So that's why we will not use anti-clockwise. So when this case happens, no matter you put nitro as carbon number 1 or fluoro as carbon number 1, we still get 1 and 3. Okay, 1 and 3, 1 and 3. So if in this case, then we will give the lowest number, follow the alphabetical order, which will become fluoro-nitrobenzene. So the position 1, 3 can be simplified using the M, which actually known as meta. So if you notice, two substitutes are opposite to each other like this. So basically, it's referred to the number 1 and 4. So it will known as 1,4-dimethylbenzene. So the symbol for 1,4 is para, P. If you still remember, just now we say that toluene is a benzene ring with a CH3. So, and then the 4-methyl here basically is referred because already 1, 2, 3, 4. So this is the 4-methyl toluene. So if you found that using the common name is a bit confused, so never mind, we just fix with the original condition. When benzene have 2 substitutes, so you just try to make sure you give the lowest number to the substitute. No matter, it can be either clockwise or anti-clockwise. After that, remember to give the name according to the alphabetical order. Okay, let's continue to tutorial question number 3, which we need to draw the structure formula for the following compound. So as we know, toluene is a benzene ring with a CH3. And then here mentioned p-methyl, so P is stand for 1, 4. So now if we draw the structure, normally we will follow the clockwise. So 1, 2, 3, 4. 4 is opposite, another CH3. So p-methyl toluene. B is O-nitrobenzoic acid. So as we know, benzoic acid is a benzene ring, and then there is a COOH attached to the benzene ring directly. Nitro, O is auto, which is 1, 2. So NO2 will be at the second carbon. And then C, phenol. So we can draw the structure of phenol first. With the OH, meta is stand for 1, 3. So 1, 2, 3. So 3 nitro. Again, nitro is NO2. D, paramethyl benzaldehyde. Benzaldehyde is a benzene ring, and then there is carbon double bond O, hydrogen, benzaldehyde. Again, para is 1, 4, so opposite consists of a methyl group. So this is the structure formula for these 4 compounds. Okay, sometimes you may notice that there is a few functional group in a benzene derivative compounds. For example, we have bromo, hydroxyl, and also carboxyl group. So when we have these 3 functional group, which one will be the parent? So we have to follow this priority. So basically, always remember that carboxylic acid or carboxyl group consists of the highest priority, and then the lowest priority will be the carbon-carbon single bond and also halogen. So for example, in this case, we have 3 functional groups, but the one with the carboxyl group, it has the highest priority, so it will given the 1. And then we can either clockwise or anti-clockwise to do the numbering. So if we clockwise, so 1, 2, 3, 4, 5, and 6. But if we do it anti-clockwise, in this case we will get 1, 2, 3, 4, 5, and 6. So for red color, we are going to use 1, 3, and 4. 1, 3, and 4. If we use green color, is 1, 4, and 5. 1, 4, and 5. So based on here, we know that 1, 3, 4 has the lowest number. Okay, so that is why we're going to give the numbering 1, 3, and 4. Okay, so because of 1 is the benzoic acid, so we no need to put the number 1, and then we need to follow the alphabetical order. So that's why 4 bromo followed by 3 hydroxy benzoic acid. So in this case, we have COOH, NH2, OH and also Cl. Again, we have 4 substituents. So COOH has the priority, so also will known as benzoic acid. For this case, we will going to use clockwise method. So NH2 is amino, OH is hydroxy, and then Cl is chloro. So based on here, A comes first, okay? We follow alphabetical order. So A comes first, so 2 amino, followed by C, 5 chloro, and then followed by H3 hydroxy benzoic acid. Okay, these are the special group at where the structure of the benzene may add as the substituent. For example, if we have C6H5, which if we draw the structure will look like this. So this is phenyl group. So if we have the bromine here, so we cannot is if we take the benzene ring as the parent, so it will known as bromobenzene. Okay, basically this is correct because bromine has the lowest priority. Okay, this one is follow IUPAC name. However, because of there is special condition at where if there is C6H5, we cannot use as phenyl, and then this one become Br become the parent. So when it become the parent, halogen become the parent, it will end with IDE. So that's why it's phenyl bromide. So if the OH attached to the C6H5 recall, so that's why it's phenyl plus hydroxyl OL, so phenol. For another condition, we know it as benzyl. Benzyl means a benzene ring attached with a CH2. So this one will known as benzyl bromide and benzyl alcohol. Okay, now we look at the tutorial question number 2. Now they give us the structure and we need to give the IUPAC name. Okay, so very obvious. For this case, the benzene will be the parent because the carbon-carbon single bond has the lowest priority. And then we have this substituent have 3 carbon is propyl. But this propyl is not a straight chain propyl, but they have branch, okay, because it is bonded to the second carbon. So this one is isopropyl benzene. Structure B, again, we see there is carbon-carbon single bond. So priority is the lowest. So benzene will be the parent, and then this substitute with 2 carbon. So the name of the substitute is ethyl. Continue with the parent name benzene. So then next we have NH2 attached directly to the benzene ring. So this one, the common name is aniline. Next one, donkey, also have a substituent which consists of 4 carbon. And then this carbon bonded to the benzene ring is the tertiary carbon. So that's why the structure for this compound is third. And then consists total 1, 2, 3, and 4 carbon. So third butyl benzene. For this one, we will take this one as the special name, a benzene ring with the CH2, which we will know it as benzyl. And then the chlorine will become the parent, so it will become chloride. Next one, the carbon-carbon double bond as the parent, so it's ethene. And then the benzene ring as the substituent, which will known as phenylethene. Next tutorial question, question number 4. Give the reason why benzene is insoluble in water but dissolve readily in organic solvent. So in this question, we have 2 parts. Okay, so basically we know it is related with the solubility. So as we know, if solubility, we need to relate with the intermolecular force. So benzene with the formula C6H6, so we know it is a non-polar molecule, while water is polar molecule. So non-polar and polar molecule, they will have different intermolecular force. So you may mention that benzene is non-polar molecule, while water is polar molecule. Therefore, benzene cannot form hydrogen bond with water. So from here, we roughly have the idea that the intermolecular force of the benzene is not hydrogen bond. Okay, then second part of the question is dissolve readily in organic solvent. So you can mention both benzene and organic solvent are non-polar molecule. Okay, so benzene can form when the was forced with organic solvent. So from this statement, then we know that both benzene and organic solvent consist of van der Waals forces. So I think this video will end up from here. So next video, we will focus on the chemical reaction of benzene, which benzene generally will undergo electrophilic aromatic substitution. Okay, see you in next video. Bye.